Welcome to this lecture on Illustrative Examples of Riemann Integrability by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon. Good afternoon. So, although we have completed our Riemann part, but since today's last class of this week, so we will not start the new topic, and we will continue with Riemann integration only. Okay. So we'll do some examples of Riemann integration, and if you have any doubt, you can ask that also. So this whiteboard is visible to everyone.
Yes, sir.
Okay, so yesterday we did two examples. We will continue with that, and we will prove some more examples, similar type of questions. We will do it. Okay. So this is the first question that we have today. Show that if f is a continuous real valued function on closed interval a b satisfying a b fx gx dx equal to 0 for every continuous function g on closed interval a b, then fx equal to 0 for all x belonging to a b. Yes. How you will prove this? So we are given that AB fx gx dx is equal to 0 for every continuous function g on AB. Then fx equal to 0 for all x belonging to AB. Yesterday we did a result, right? What we did, if f is greater than equal to 0 and a to b f is equal to 0, f is continuous, then f is equal to 0 for all x belonging to AB, right? Yes. So how can we use this result here? How can we make use of this result here? If you take gx equal to 1, then you get abf is equal to 0 for all x, abf equal to 0, but this does not imply f is 0. Why? Yes. Why we cannot conclude this from here? Because we don't have this condition, right? F is not given to be positive, so we need something positive to apply this result. So what should we do? जी को ऐसा कौन सा फंक्शन लेके हमें हमारे पास इंटीग्रल में पॉजिटिव आ जाए जिससे हम कंक्लूड कर पाए कि f will be 0. Yes, let gx equal to fx. Yeah, since ab fx gx is equal to 0 for all x belonging to ab, sorry, for all continuous real valued function g, for all continuous real valued function g. So this implies AB fx in particular we can take fx gx equal to fx, right? Taking gx equal to fx because f is continuous, so we can take gx equal to fx. So this implies AB fx whole square dx is equal to 0, that is AB f square is equal to 0. Now since f square is greater than equal to 0, f square is continuous on AB. Why it is continuous f square? Yes, why f square is continuous on AB?
Greater than 0.
Yes. algebra of continuous function, product of two continuous function is continuous, right? So this is continuous. F square is product of f into f. F is continuous. Okay, so this implies f square equal to 0. Yeah, f square x equal to 0 for all x belonging to, that is fx equal to 0 for all x belonging to ab. Is it fine, everyone? Yes. Clear?
Yes, sir.
Okay, how we shall prove this question? Suppose f and g are two continuous function on closed interval ab and gx is greater than or equal to 0 for all x belonging to ab. Prove that there exists c belonging to ab such that a to b fx gx dx equal to fc times ab gx dx. Yes. It is kind of intermediate value theorem, right? यहाँ पे ये उसी तरह का इंटरमीडिएट वैल्यू थ्योरम, बट यहाँ पे एफ सी है, राइट? दिस इज एफ सी. सो तुम्हें क्या करना होगा अगर इसको इस तरह से देखो, इफ यू लुक एट दिस एफ सी इक्वल टू 1/a to b gx dx into a to b fx gx dx. ठीक है? Is it fine? So it is similar to intermediate value theorem. So basically what you will have to do is you will have to show that this value lies between two values of f, two images of f. तो intermediate value theorem for continuous function apply कर पाएंगे. So आप बताओ कुछ ऐसा जिससे कर पाओ. Let us write its proof. So दो केसेस में करना पड़ेगा. पहले क्योंकि अभी हम मैं बता रहा था ना डिवाइड करना पड़ सकता है. तो पहला केस है कि ये नॉन जीरो होना चाहिए. अगर ये जीरो होगा तो क्या होगा? If ab gx dx equal to 0, then as gx is greater than or equal to 0, gx is given to be positive and g is continuous on ab. So what does this imply? So this implies gx is equal to 0 for all x belonging to ab. So this implies fx gx is equal to 0 for all x belonging to ab. Hence a to b fx gx dx is equal to 0, which is equal to fc times a to b gx dx for any c belonging to ab. You can pick any c because ये term 0 है ना. So you can take any c और फिर भी fc को multiply करोगे तो 0 से तो 0 ही आएगा. So these two are equal, right? So take the case. So suppose integral. So hence hence we are done in this case, right? Hence we are through in this case, right? So we will assume that gx is non-zero. So assume that a to b gx dx is not equal to 0. That is, it is greater than 0, right? Because gx is positive, is greater than 0. Okay, is it fine?
Yes, sir.
Let L इक्वल टू, इसको नाम दे देते हैं क्योंकि इसको डिवाइड करना होगा तो नीचे डिनोमिनेटर में लिखना टफ हो जाएगा. सो वी आर गिविंग इट अ नेम L and so this implies gx is greater than 0 for some x, right? Yeah, g is, yes, इसको चलो ऐसे छोड़ो, इसकी जरूरत नहीं अभी हमें. ठीक है, सो L को हमने ये ले लिया. We will have to take infimum m equal to infimum of f over ab. ठीक है, and capital M equal to supremum of f over ab. ठीक है, so now अब हमें कुछ करना है कि ये a now m is less than equal to fx is less than equal to m for all x belonging to AB, right? So this implies mgx is less than equal to fxgx is less than equal to mgx for all x belonging to AB. Why is it so? इससे ये क्यों imply हो रहा है? हम gx मल्टीप्लाई कर रहे हैं तो इनइक्वालिटी क्यों नहीं चेंज हो रही? Why inequality is preserved when we are multiplying it by gx? Yes, can someone explain this fact? Inequality कब change नहीं होती? If you are multiplying something by किसी inequality को if you are multiplying by something, under what condition inequality does not change?
जब पॉजिटिव हो
Yes, the thing that we are multiplying that should be positive. So यहाँ पे gx it is given to be positive, right? We are given gx to be positive, so that's why this inequality is preserved. ठीक है, ये ध्यान रखना है इन चीजों को. If you are multiplying something, so you should make sure if you want to preserve your inequality, you should make sure that the term with which you are multiplying that should be positive. So it is positive, so we can have this. Right? Now since integration preserves order, right? Order is preserved by integration. So हमारे पास क्या आ जाएगा? Because this is less than equal to this is less than equal to this, so this implies integral of ab m times gx dx is less than equal to integral of ab fx gx dx is less than equal to integral of ab and gx dx. Now because m and capital M are independent of this, so this implies m ab gx dx is less than equal to ab fx gx dx is less than equal to m times ab gx dx, right? So that is ml is less than equal to ab fx gx dx is less than equal to ml. Now because L is positive and L is strictly greater than 0, so we can divide this inequality by L and still our inequality will be preserved, right? So m is less than equal to 1 by L times AB fx gx dx is less than equal to capital M, right? Up by maximum minimum theorem, since f is continuous on closed interval AB, so by maximum minimum theorem, there exists C1 C2 belonging to AB such that f of C1 is equal to M and f of C2 equal to M. So then from A we have FC1 is less than equal to 1 by L times AB fx gx dx is less than equal to FC2. Now by intermediate value theorem, because this value lies between two images of f, so by intermediate value theorem there exists C belonging to C lying between C1 and C2. Okay, that is C belonging to C belonging lying between C1 and C2, that is C belongs to AB, such that FC is equal to 1 by L times A to B fx gx dx, that is A to B f gx dx fc times A to B gx dx is equal to A to B fx gx dx. So hence proved. Is it fine everyone?
Yes, sir.
So it was similar to intermediate value theorem. So हमने उसी तरह से इसको किसी तरह हम इस वैल्यू को हम किसी तरह बीच में ले आए और then we were able to apply intermediate value theorem. ठीक है. Yes, how you will conclude that this function is integrable? Sin 1 by x if x is not 0 and 0 if x is equal to 0 is integrable on -1 to 1. Yes, can someone explain this? Why it will be integrable? हमने करा हुआ है. इसके set of discontinuities क्या है? Where this function is discontinuous?
0.
At x equal to 0, right? So और सब जगह कंटिन्यूस है. तो अगर किसी फंक्शन के फाइनाइट नंबर ऑफ डिसकंटिन्यूटीज होते हैं तो वो सेट क्या होता है? वो फंक्शन क्या होता है? इंटीग्रेबल, राइट? सो इससे डायरेक्ट आ जाएगा. The set of discontinuities of f is 0, which is a finite set, hence f is integrable on -1 to 1. ठीक है, सिंपल. Is it fine everyone?
Yes, sir.
Okay, let us take another question. Let f be a bounded function on closed interval ab. Suppose there exist sequences un and ln of upper and lower Dabov sums for f such that limit n tends to infinity un minus ln is equal to 0. Show that f is integrable on ab and abf is equal to limit n tends to infinity un equal to limit n tends to infinity ln. Yes, how you will prove this? un and ln are sequence of upper and lower Dabov sums for m. ठीक है, दे ऐसा नहीं है ये ln कैन बी डिफरेंट फ्रॉम un. ठीक है, ये ln f कैन बी फ्रॉम फॉर डिफरेंट पार्टीशन और un इज uf qn इस तरह से हुआ. ठीक है, दे मे नॉट बी सेम फॉर सेम पार्टीशन के लिए नहीं हो सकता, मे बी ना हो. ये बस ये सीक्वेंस ऑफ अपर सम्स एंड लोअर सम्स दिया हुआ है. ठीक है, सो ये मत सोचना कि ln जो है वो सेम पार्टीशन के लिए है और p and un भी सेम पार्टीशन के लिए. दे मे बी फॉर डिफरेंट पार्टीशन आल्सो, राइट? सो हाउ यू विल प्रूव इट? यस, इफ यू रिमेम्बर जो हमने रिजल्ट करा था, एक हमने रिजल्ट कर रखा है सेम सीक्वेंशियल क्राइटेरिया. उसमें क्या है कि अगर लिमिट n tends to infinity ufpn is equal to limit n tends to infinity lfpn, then f is integrable over ab and the value of the integral is the limit of this function, right? Right, if and only if. In fact this result was if and only if. Remember we did a result after Darboux theorem, right? लेकिन यहाँ पे what is different is that these two sequences may be different. ठीक है, ये सीक्वेंस ऑफ अपर बाउंड है, दूसरा सीक्वेंस ऑफ लोअर Darboux सम है, बट दे मे बी फॉर डिफरेंट पार्टीशंस, दे आर नॉट सेम. ठीक है, सो हमें ये नहीं दिया हुआ. सो क्या करना चाहिए हमें? So let Ln equal to LFPN and UN equal to UFQN for all n belonging to n. So partition may be different, right? Pn और Qn different हो सकते हैं. अब हमें ये सेम के लिए करना है, सेम पार्टीशन के लिए करना है, तो क्या करना चाहिए हमें? Yes, what should we do now? We want it for the same partition. Yes. अगर सेम पार्टीशन, दो डिफरेंट पार्टीशन दिए हुए हैं, हमें सेम पार्टीशन के लिए रिजल्ट कोई होल्ड कराना है, तो क्या करते हैं हम? यस, बताओ. Pn union Qn, common refinement of both Pn and Qn. Then we have, what we will have? रिफाइनमेंट लेते हैं तो उसका लोअर सम क्या होता है? बढ़ता है या कम होता है? यस. राइट. इज इट फाइन?
Yes, sir.
ठीक है ना, क्योंकि रिफाइनमेंट है, Rn इज अ रिफाइनमेंट, सो LFPN will be smaller than LFRN, and LFRN, this is usual result, and UFRN is less than equal to UFQN. So we have this result now. So this implies 0 is less than equal to UFRN minus LFRN is less than equal to UN minus Ln, right? Difference between these two will be greater than the difference between these two. So we have this result, right? अब ये जो है, this is going to 0 by Squeeze theorem, क्योंकि ये 0 ऑलरेडी है, ये limit n tends to infinity, UFRN minus LFRN is equal to 0, right? Since limit n tends to infinity, UN minus Ln is equal to 0. So by Squeeze theorem we have this, and this implies, क्योंकि इन दोनों का लिमिट 0 आ गया, that means we can make them less than epsilon for some partition. So f is integrable over AB. ठीक है, या इसको इस तरह से भी लिख सकते हो. So this implies limit n tends to infinity, UFPN is equal to limit n tends, sorry, Rn LFRN. So this implies yes. So this implies f is integrable over AB, and integral ABF is equal to limit n tends to infinity, UFPN equal to limit n tends to infinity LFRN. Sorry, और ये जो है this will come out to be equal to UN, they are equal to, ठीक है. हमें सॉरी बीच में वो दिखाना था, तो यहाँ पे स्क्वीज थ्योरम लगाना पड़ेगा हमें, ठीक है. वी विल हैव टू अप्लाई स्क्वीज थ्योरम हियर. ओके. Is it fine? We will have to apply squeeze theorem here, since limit n tends to infinity, un minus ln is equal to 0. Also, as un and ln are bounded sequence. So this implies limit n tends to infinity, ln is equal to limit n tends to infinity, un, right? So from star and double star इसको इस तरह से करते हैं. From star and double star using squeeze theorem, we have limit n tends to infinity, ln is equal to limit n tends to infinity, lf rn is equal to limit n tends to infinity, uf rn is equal to limit n tends to infinity, un. ठीक है? Hence f is integrable over ab and इंटीग्रल, क्योंकि हमें क्या दिखाना है कि ये हमें ये दिखाना था कि un का जो लिमिट होगा दैट विल बी इंटीग्रल, इसलिए हमें ये रीराइट करना पड़ा है ये. ठीक है, क्योंकि हमें चाहिए कि ये दोनों इंटीग्रल इक्वल आ जाएं, ये दोनों ये इनके बराबर आ जाए इन दोनों के. सो ये शो करना था, इसलिए फिर इस तरह से रीराइट करा है हमने, नहीं तो अदरवाइज पहले वाला भी सही था हमारा, उसमें गलती नहीं थी. ठीक है, इज इट फाइन एवरीवन? Is it fine?
Yes, sir. Yes, sir.
Okay. Now consider this question. This is slightly yesterday we did what we did yesterday. इसको same question करा था, उसमें एक चीज अलग थी. Yes, what was that? If you remember, yesterday we did this question, same question, लेकिन वहां पे बस हमारे पास यहाँ पे 16 pi cube था. We didn't have 1/3 in the denominator, right?
Denominator.
लेकिन अब यहाँ पे 1/3 इन द डिनोमिनेटर आ गया है, मतलब 3 आ गया डिनोमिनेटर के अंदर. सो वी कैन नॉट यूज दैट इंटरमीडिएट वैल्यू थ्योरम है, राइट? क्योंकि उससे तो 16 पाई क्यूब आ रहा है और हमें तो उससे छोटा नंबर चाहिए बाउंड के लिए. तो वी विल हैव टू टेक सम अदर अप्रोच. ओके, इज इट फाइन? So we will have to take some other approach. So what should we do then? Yes, consider. So we will start with this minus 2 pi to 2 pi x square sin 8 ex dx. So this is less than equal to क्या हो जाएगा? minus 2 pi to 2 pi x square sin 8 ex dx, right? वैसे तो इट विल कम आउट टू बी पॉजिटिव, क्योंकि ये छोटे से बड़े नंबर है यहाँ पे, तो ये पॉजिटिव रहेगा, इंटीग्रेंड भी पॉजिटिव है. सो इसलिए वी कैन रिमूव द मॉड आउटसाइड. ओके, इज इट फाइन? दिस वन इज फाइन. यस, ये रिजल्ट हमने यूज कर लिया, दैट ए बी एफ dx abf is less than equal to ab mod f, right? Remember, we have used this result. So this is, now we can replace again, this x square is less than equal to this, so minus 2 pi to 2 pi x square dx, since x square sine 8 ex is less than equal to x square, right? Because this can be replaced by 1 and integration preserves order. ठीक है, सो वी गेट दिस. अब इसको x स्क्वायर है तो यू कैन रिमूव द मॉड, सो दिस इज इक्वल टू minus 2 pi to 2 pi x square dx. x square को इंटीग्रेट करोगे तो you will get x cube by cube minus 2 pi to 2 pi, which is equal to 8 pi cube by 3 minus 8 pi cube by 3, which is equal to 16 pi cube by 3. Hence integral minus 2 pi to 2 pi x square sine 8 ex dx is less than equal to 16 pi cube by 3. तो अगर वो वाला रिजल्ट भी प्रूव करना हो 16 पाई क्यूब वाला, तो इसको इससे इससे इस मेथड से भी कर सकते हो उसको, राइट? क्योंकि दिस इज लेस देन 16 पाई क्यूब, राइट? सो यू कैन गेट दिस. सो जो कल हमने करा था उसको इस मेथड से भी कर सकते हो. इज इट फाइन एवरीवन?
यस सर.
यस.
सर एक बार प्रीवियस वाला पेज दिखा दीजिए. ओके सर.
ठीक है, ओके. लेट अस टेक वन मोर क्वेश्चन. नाउ इट इज डिफाइंड ऑन रैशनल एंड इररेशनल. ठीक है, इस तरह के फंक्शन आते हैं और विच इज डिफाइंड ऑन रैशनल एंड इररेशनल. तो सबसे पहले तो ये देखना होता है कि इन दोनों में से विच वन इज बिगर. ठीक है, इज इट क्लियर? जब भी तुम्हें इस तरह के रैशनल और इररेशनल पे डिफाइंड होगा फंक्शन, ठीक है, कुछ x प्लस टू या माइनस थ्री एक्स प्लस सिक्स, ऐसे कुछ भी डिफाइंड हो, ठीक है, तो तुम्हें क्या फर्स्ट क्या देखना है तुम्हें कि कौन सा पहले बड़ा है इनमें से. ठीक है, इज इट फाइन? लेट अस सी व्हिच वन इज बिगर आउट ऑफ दीस टू. सो जस्ट सब्ट्रैक्ट. सो इन दोनों का सब्ट्रैक्शन लेना होगा, तो अब रूट में से सब्ट्रैक्ट करना तो मुश्किल है. सो व्हाट वी विल डू, वी विल टेक द स्क्वायर ऑफ दीस टू. ठीक है, so 1 minus x square ka square minus 1 minus x ka square. Let us see what we get. So this is 1 minus x square minus 1 plus x square minus 2x. So which is 1 minus x square minus 1 minus x square plus 2x. So here we get 2x minus 2x square. So you can take 2x outside. It is 1 minus x. Is it positive or negative on 0 1?
Positive.
Yes, it is positive, which is greater than equal to 0 for all x belonging to 0 1. So this implies your root 1 minus x square whole square is greater than equal to 1 minus x whole square. Both terms are positive, this term and this term in the bracket, both are positive on 0 1. So this implies root 1 minus x square is greater than equal to 1 minus x, since 1 minus x square is positive and 1 minus x is also positive on 0 1. So we can take we can preserve the inequality, right? Is it fine? So this means this one is always bigger than this one. So हमारे पास UFP किससे आएगा? UFP will come from this and LFP will come from this. ठीक है?
ओके सर.
So what we do, we consider any partition of 0 1. ठीक है सर, इसको ध्यान रखना कि UFP will come from अपर सम, क्योंकि हमेशा सुप्रीमम किसी भी इंटरवल में लोगे, किसी भी इंटरवल में लोगे तो फंक्शन कौन सा लेगा? रैशनल वाली वैल्यूज, क्योंकि दोनों में रैशनल रैशनल है. दिस वन इज ऑलवेज बिगर देन दिस, सो यू विल गेट, इससे इस पे सुप्रीमम आएगा, इस पे इनफीमम आएगा. फाइन.
यस सर.
ओके, So now let Pn equal to 0 I by 1 by n 2 by n up to n minus 1 by n and 1. II is your I minus 1 by n to I by n, right? And delta I is equal to 1 by n and mi, small mi, what will be infimum? Yes, what will be this? This will come from, अब ये भी देखना चाहिए, हाँ एक चीज और देखना होगा कि विच वन, कौन सा डिक्रीजिंग है कौन सा इंक्रीजिंग है इनमें से। दोनों को डिफरेंशिएट करोगे तो क्या आएगा? पॉजिटिव या नेगेटिव ऑन 0 1। both root 1 minus x square and 1 minus x are decreasing on 0 1,
0,
राइट?
1.
क्योंकि इसको डिफरेंशिएट करोगे तो -1 आएगा, इसको डिफरेंशिएट करोगे तो 1/2 रूट 1 माइनस इंटू -2x, तो माइनस साइन आएगा, राइट? सो बोथ आर नेगेटिव, सो डिक्रीजिंग फंक्शन। सो इसलिए इनफिमम कौन से, अगर फंक्शन डिक्रीजिंग होता है तो इनफिमम किस पे आता है? यस,
1 minus.
राइट हैंड पे आएगा, इस पे आएगा। और क्योंकि जो है रैशनल इरेशनल वाला छोटा है, ये वाला फंक्शन यूज होगा, ठीक है? क्योंकि ये छोटा है तो ये वाला फंक्शन यूज होगा। सो यू विल गेट इन mi इज इक्वल टू 1 माइनस I by n एंड सुप्रीमम इज इक्वल टू m ऑफ fi। ये लेफ्ट हैंड पॉइंट पे आएगा और लेफ्ट हैंड पॉइंट पे दूसरा फंक्शन यूज होगा, रूट 1 माइनस I माइनस 1 स्क्वेयर बाई n स्क्वेयर। फाइन, इज इट फाइन?
Yes, sir.
Now what we will do is we will क्योंकि अब इन दोनों को mi minus mi निकालना टफ है, so again we will take mi square minus mi square. You consider mi square minus mi square, so which is 1 minus I minus 1 square by n square minus 1 minus I square by n square plus 2I by n, right? So you get is 2I by n माइनस इधर से क्या आ जाएगा तुम्हारे पास, i माइनस 1 बाई n स्क्वायर, तो कॉमन निकाल लो, राइट? इन दोनों में से, और ये क्या हो जाएगा, i स्क्वायर प्लस i माइनस 1 होल स्क्वायर, राइट? सो व्हेन यू विल i स्क्वायर प्लस i माइनस 1 होल स्क्वायर, सो i माइनस 1 होल स्क्वायर इज i स्क्वायर प्लस 1 माइनस 2i, राइट? इज इट फाइन?
Yes, sir.
सो यहाँ पे क्या आ गया तुम्हारे पास, यस, 2i by n minus 1 by n square, 2i square plus 2i plus 1, right? So mi square minus mi square. So this implies mi minus mi m, इसको चलो इस यहीं पे लिख लो, नेक्स्ट स्टेप में फिर डिवाइड कर लेंगे, which is equal to mi minus mi mi plus mi, right? Is it fine? Now mi plus mi is bounded by is लेस देन इक्वल टू 2, इफ यू सी द फंक्शन की मैक्सिमम वैल्यू 1 आ रही है, ठीक है, दोनों फंक्शंस के लिए, इस पे भी 1 आएगी, इस पे मैक्सिमम वैल्यू 1 आएगी, ये डिक्रीजिंग फंक्शन है, तो इसकी जो मैक्सिमम वैल्यू है वो 0 पे आएगी, और 0 पुट करोगे तो दैट विल बी 1 1, राइट, बोथ आर डिक्रीजिंग फंक्शन, सो मैक्सिमम वैल्यू इज 1, so the mi is less than equal to 1, small mi is less than equal to 1, so overall these are less than equal to 2. Is it fine? So if we replace by 2, what will happen? We're replacing by something greater, so 2 times mi minus mi is greater than equal to 2i by n minus 1 by n square, 2i square plus 2i plus 1, right? So mi minus mi is greater than equal to I by n minus 1 by n square, I square plus I plus 1 by 2, right? Is it fine? So UFPN minus LFPN, if you will calculate, this will be summation I equal to 1 to n mi minus mi delta I, so which is greater than equal to, you can replace this by this term, so summation I equal to 1 to n I by n minus 1 by n square I square plus I plus 1 by 2 into 1 by n, right? So then you, when you will simplify this, ठीक है, इसको summation I है, summation I square है, this is, so I पहले तो I वाले terms को एक साथ कर लो, because we will be getting summation I, so this can be written as I equal to 1 to n I 1 by n minus 1 by n square, right? So we made a mistake here, minus 2i, so ये minus 2i है, this is minus, this is minus, 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 or we will get here plus minus I minus I, so 1 by n you can take outside, ये 1 by n, और ये जो है तुम्हारा क्या हो जाएगा 1, इसको you can, so let me just rearrange and write, so this is nothing but equal to ये 1 by n इसके साथ collaborate होके it will 1 by n square plus 1 by n cube summation I equal to 1 to n I, right? We have clubbed these two terms together, ठीक है, so I आ गया, अब I square वाले term को you can club it, so you will get minus 1 by n cube summation I equal to 1 to n I square, और 1 by 2 वाले term को you can write, so you will get, क्या आएगा इसको, क्योंकि ये तो n times add हो जाएगा, so you will get minus 1 by, because this n will get cancelled, you will get minus 1 by 2n square, right? Is it fine?
Yes, sir.
तो अब ये क्या है, this is n plus 1 n plus 1 by 2 minus 1 by n cube, what is this, sum of this क्या आता है, sum of I square का sum क्या होता है, n plus 1 2n plus 1 by 6 minus 1 by 2n square, so अब हमें बस लिमिट लेना है, ठीक है, तो लिमिट n tends to infinity UFPN minus LFPN is greater than equal to, so यहाँ पे 1 by n cube, तो 1 by n cube तो इसको भी 0 बना देगा, so 1 by n square के साथ आएगा, so that you will get is 1, क्योंकि ये 1 हो जाएगा, ये 1 plus 1 by n, ठीक है, so when you will simplify you will get 1 by 2 here, right? ठीक है, n क्यूब इसको ये 1 हो जाएगा, ये यहाँ पे तुम्हारे पास 2/6 आ जाएगा, -2/6, और ये तो 0 हो जाएगा, सो यू विल गेट 1/2 -1/3 which is 1/6 which is greater than 0. ठीक है, सो ये 0 होना चाहिए था लिमिट, सो हेंस f is not integrable over. Fine everyone?
Yes.
This is how you can do such questions. So this is not tending to 0. So what about this function? F is defined from 0, 1 to r. Fx equal to 2n if x is equal to 1/n for some n belonging to n, and 0 otherwise. Is f Riemann integrable on 0, 1? Yes, can someone explain this? Why? What about this function? Is it integrable or not? इसकी set of discontinuities क्या है? What are the set of discontinuities of this set? Yes. What are the set of discontinuities of this set? It is not integrable on 0, 1. Why? If you take the sequence 1 by n in 0, 1, then f of 1 by n is 2n, right? So limit n tends to infinity, f of 1 by n is infinity. This implies f is not bounded on 0, 1, right? Or bounded नहीं है तो integrable नहीं है. And this implies f is not integrable on 0, 1. How can you prove the इसको और किस तरह से कर सकते हो अनबाउंडेड शो करने के लिए? फॉर एनी रियल नंबर के ग्रेटर देन 0, यस, इसके कॉरेस्पॉन्डिंग कोई n बताओ. 1 by k is greater than 0, so by Archimedean property there exists m belonging to z positive such that 1 by m is less than 1 by k. ठीक है, that is m is greater than k. So f of 1 by m, f of 1 by m is 2m which is greater than k, so that is f is unbounded, right? किसी भी real number के लिए you are able to find some point in the domain which is greater than that number. So there are two ways to prove it. Alternate way to prove unbounded. ठीक है, so this is it fine? So there are two ways to prove it unbounded, so you can show unbounded. अगर if you see this question, अगर इसी को मैं इस तरह से define कर दूं, if I define it like this question, let f equal f from 0, 1 to r as fx equal to 2 if x equal to 1 by n for some n belonging to n and 0 otherwise. Is f Riemann integrable on 0, 1? And now if you look at this function, now it is bounded, right? Earlier it was unbounded, but now it is bounded क्योंकि इसका bound तो 2 है. So this function is bounded on 0, 1, right? So अब क्या है? Is it continuous? Set of discontinuities of f on 0 1 is, what are the set of discontinuities of this set? Can someone prove this result? इसको prove करना, ठीक है? Take it as an assignment, ठीक है? कैसे प्रूव करोगे, या कोई जल्दी बता दो, अभी कितना टाइम है? Okay, we are above time, so prove this yourself. So limit point of this set of discontinuities is, so set of, yes, what is the set of limit points? 0, which is finite. Hence, f is integrable over, ठीक? इसको ट्राई करना प्रूव करने की सेट ऑफ डिसकंटिन्यूटीज ये क्यों आती है, कि इस पे कंटिन्यूअस कोई क्यों क्यों नहीं, अगर इसके बाहर कोई पॉइंट लाओगे तो उस पे कंटिन्यूअस है, बट इस पे कंटिन्यूअस नहीं है. जस्ट ट्राई, गिव इट अ ट्राई. फाइन एवरीवन? यस, इज इट क्लियर? तो मेरी छोटी सी पैर डाल दे. इज इट क्लियर एवरीवन?
कोई ना यार, बात तो सेट सही है ना आपके? सेट तो ना पहले
Mukesh, please unmute yourself or mute yourself, Mukesh. Okay, so this much is enough for today. Any questions anyone want to ask? Okay, so as there are no question, I am ending this class. Bye everyone. Have a good day.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.